Hello. In this video, we're going to look at how to figure out the area of a regular polygon. And in this particular video, I'll be looking at a pentagon, but what we're about to do can be done for any regular polygon. So, the first thing that will be very helpful is to recognize that a pentagon or a polygon can actually be separated into simpler shapes that we are more familiar with working with. And the simpler shape that will help us is the triangle. We can actually separate our polygon into separate triangles. In this case, we have 1, 2, 3, 4, 5 triangles. So the number of sides that you have will be actually the same as the number of triangles that you're able to separate your polygon into. All right, but how does that help us? Well, we know that the area of a triangle is equal to half base times height. So the area of a triangle, so I'll just put triangle there for short, is equal to half base times height. So let's look at triangle number 4, just because it's nice and easy to see right there at the bottom. Oh my goodness. Let's fix that up a bit. All right, so we're looking at triangle 4. If the measure of the sides of our pentagon is just, let's call it side, then in order to figure out the area of this triangle, it would be a half side, because that's our base in the triangle's case, times height. Now, the height of this triangle has a certain name. So there is a name for the thing that goes from the center of our polygon perpendicular to the side, and that's called the apothem. I'm not sure if I'm pronouncing it right, but it's spelled A-P-O-T-H-E-M. All right, so in order to figure out the area of the triangle, so triangle 4, it is half base, which is called side in this case, times height, which is called the apothem. So half side times apothem. Now, that's just the area of one triangle, but we're not really trying to find the area of a triangle. What we are, in fact, trying to find is the area of all 5 triangles. So you may recall that the number of triangles is the same as the number of sides. There are actually 5 sides here because there are 5 triangles, and it's a 5-sided figure, it's a pentagon. So in order to figure out the area of the polygon, we have to multiply half side times apothem by the number of sides, so let's call that n. So again, in order to figure out the area of our polygon, we're multiplying a half by the side length of the polygon, by the apothem length, and then, of course, by the number of sides. So make a note of each thing just so you do not forget. S is the side length of the polygon, and remember it's a regular polygon, so all of these things are the same. A is the apothem length. And or n is just the number of sides. Okay, but, oops, that should say number of sides. But here's the problem. Sometimes we are not given the apothem length, sometimes we are expected to find it. So let's talk about what to do in that case. Okay, so here we have a question that's asking for the area of the pentagon below. And so if we take a look at the pentagon and see that we have only the side length, we get a little bit stuck if we try to use the formula that we just came up with, which is area of a polygon equals a half side length times apothem length times number of sides. We get stuck because, yes, we do have the side length, it's 3, and we do have the number of sides, it's 5, but what is that apothem length? We don't know yet, but we can find it, because what we can do is, and I already started here, we can put a circumscribed circle around our polygon and it will help us. And let's see how. All right, so I'm going to take my polygon and I'm going to separate it into triangles, as we've seen that we can do. So these triangles should be congruent. I'm doing the best job I can here. They're not, but they should be. Okay, so when we see the circle around the polygon, then we know something about the angles internal here. We know that the sum of the angles should be 360 because it's the sum of the internal angles of a circle. All right, so we also know that there are 1, 2, 3, 4, 5 angles within, and they're all supposed to be congruent, which means that each angle should be a fifth of the 360. So, for example, over here we can say that the measure of angle 1 is equal to 360 over 5. So angle 1 is 72 degrees. And so are all of the other angles within here. So, how does that help us? Well, let's draw in an apothem and see. So I'm drawing in that apothem that we don't know, but we do know that this whole angle from here to here, we know that that angle is 72 degrees, which means that we know that this part of the angle is a half of 72 degrees, that is 36 degrees. All right, so we're getting somewhere, I think. If we create, or if we focus on, because it's actually already created, if we focus on a right triangle here, we know, well, we knew that this whole thing is 3, because the side length is 3. So we now know that half of that is 1.5. And then now we can find the apothem length. It might help if I draw that triangle off to the side so you can focus on it. So here we go. I'm just redrawing the blue triangle. That's the apothem length. That is 36 degrees. And that is 1.5. So we know how to figure out an unknown in a triangle, hopefully. If we have one side and one angle, we have to use Sohcahtoa, if it's a right triangle, of course. So let's write down Sohcahtoa. All right, so as it turns out, we have the opposite, and we want to find the adjacent, which means that we're using Toa. So tan of the angle 36. Let's rewrite that. Hold on. That's okay. Let's cross that out. So tan of the angle 36 is equal to opposite, which is 1.5, over adjacent, which we don't know. We can then cross multiply. So we get A tan 36 is equal to 1.5 times 1. And so isolating the A, we can divide 1.5 by tan 36. So I'm going to do that in my calculator. Hold on. Let me just write this down so you don't miss a step here. By tan 36. All right, so I'm going to go ahead and do that while you do it. 1.5 divided by tan 36, and I get my apothem equal to 2.064, it's 2.065. All right, so we did all this work just to find our apothem, and now we have it. So now we can go back to the original question. A half side length, which we know is 3. Apothem length, which we now know is 2.065, times the number of sides, which is 5, and we can go ahead and plug that into our calculator. A half times 3 times 2.065 times 5, and we get the area of our polygon as 15.49 approximately. So you'd want to use a little approximate sign because that's not exact. And our units are centimeters originally, so then this is centimeter squared. And that's how you find the area of a polygon.